I'll talk about some applications of microwaves, most of which you see around the room right now. But there are some new applications coming up on the horizon, and they might impact your industries. They are impacting other industries at the minute. So I'll just speak about them briefly, and you can interrupt me at any point with questions if you want. So what are microwaves anyway? Microwaves are electromagnetic waves, and they've always been here. So they're being used at the minute to actually understand the Big Bang. Now, if you don't believe in the Big Bang, that's a different issue. But microwaves that originated at the Big Bang are reaching us today. So they're constructing these massive arrays of antennas called the square kilometer arrays. There's one in England, in Oxford. There's another one in Chile. So they're using these to understand the fundamental theories of physics. But what are electromagnetic waves? Electromagnetic waves contain an electrical field and a magnetic field, and they move. So the wave part. We've understood the properties of some of these waves for a long time. So for instance, light has been used in various architectural constructions through generations. The Sistine Chapel uses light in a very novel way. We've all played with kaleidoscopes much before we understood electromagnetics. It took a couple of very clever physicists at the fag end of 19th century to formulate these mathematically. And that really revolutionized the field and led to a number of applications. It also led to the understanding that electromagnetic waves fundamentally are energy, so they contain energy. But energy is a very, very interesting thing. Energy can transmit power. So that's Tesla sitting under one of his crazy inventions in the early 19th century, transmitting power. Today, this technology is transformed into a wireless charging pod for your BlackBerry Z10, for instance. So it's taken a long while to get into our pockets, but it's got there eventually. Energy can be used to see objects. So it's been used in radar systems. So all the air traffic control radars, marine radars, everything depends on the ability of electromagnetic energy to bounce off objects. Energy can cook food. So obviously everyone's used this. Energy can also cook other things, which I'll talk about in a bit. And energy can help us communicate. So information is also energy. Information is carried within the oscillations of these waves. So we depend on this fundamentally to actually allow us to exist as a modern civilization. But all these applications which exist, what's the implication for the future? The implication is that the infrastructure has been laid. So all these applications helped us develop technology which is allowing us to democratize the process of innovation. So radars, satellite technology, all of these required a lot of investment. Governments invested in them, militaries invested in them. Now we can harness the power of these technologies. So semiconductor industry was revolutionized primarily because of investment from the military. So where are we going next? Well, there were 20,000 research papers submitted to the IEEE, the Institute of Electrical and Electronics Engineers in the USA in 2012 that deal with microwaves and related technologies. That's one organization receiving 20,000 papers. I took these papers and ran some numbers on them. So just did a cloud tagging exercise on them. And by far the biggest one is mobile communication. It's not a big surprise, it's still growing. The next one is wireless sensor networks. Then you have radar, because there's still a lot of applications for it. You have microwave processing, you have terahertz technologies, and you have RFID. I won't talk about all of these, but I'll briefly touch upon some of these aspects. Let's start with wireless sensor networks, because it gets a lot of press. What are wireless sensor networks? Wireless sensor networks are sensors distributed around a plant, around an environment, that communicate with each other and carry some critical information. So where are we seeing these already? Last year, we helped develop a wireless sensor network for a renewables energy operator. So we put sensors on each of their sensor buoys off the coast of Spain that help them improve the efficiency of their wave energy generators. So this already exists and is being tested at the minute. But marine environments don't float everyone's boats. So where else are we going to see this? So in cars, some of you already drive cars with radar systems. Most of you will in the coming years. But that's not the only technology which will come into cars. Cars will speak to each other. So each car then becomes a sensor. So it tells us where the traffic is. It tells us about the road conditions. It tells us if there's been an accident. And the authorities are looking to use this information to plan better traffic and reduce congestion in the megapolises that are springing up around the world. But where else will we see this? Because this, again, is starting to exist already. What about oil pipelines? There's a lot of research being undertaken in understanding the reasons behind corrosion in oil pipelines. There's a lot of research being undertaken in deploying sensors to measure these corrosions and leakages and temperatures in extremely cold regions. But these sensors could be deployed over hundreds of kilometers. You need them to communicate somewhere. And that's where the infrastructure comes in, because we already have the mobile communication infrastructure. All we need to deploy are clever sensors. And these sensors are being developed at the minute. But oil pipelines are not always overground. They can be underground. But that's not a problem either. We've now developed technology which allows us to communicate underwater. So we had sonar systems. Now those have been packaged down into a unit which, a bit smaller than your thumb, that can convert wireless communications into acoustic waves that travel along the pipe or travel from the seabed up to a sensor buoy or a ship on shore. And that then communicates over our existing wireless communication infrastructure. So we're actually working on a project related to this as well. Well, that's enough about wireless sensor networks. Let's talk about the other interesting aspect of microwaves. So microwaves, as I said, are energy. So that's a magnetron. There's at least one of these in every domestic microwave around the world. They can then be converted into plasma. They can be converted into heat. They can be used as a catalyst in chemical synthesis. And people are already harnessing the power of microwaves in process industries. In dewatering, for wood and paper industries, ceramics industries, textiles, and food, where using microwaves instead of conventional convection heating or hot air heating improves energy efficiencies by up to 50%. For a company which is spending, let's say, about 10 megawatt on energy every single year, that's a significant energy saving by replacing one part of the process with an alternate method. Plasma is being used in waste treatments. So obviously for sustainability reasons, there's a lot of focus on being able to reuse waste from, say, electrical goods and bringing it down into components that can be reused. So plasma can be generated using microwaves. So there's a company in the US which has just started a $1.4 billion plant just using microwave plasmas for breaking down electrical waste. It's a federal government funded project, but once it kicks in, there are inevitable commercial implications for it. And microwaves are by far the most efficient way of generating plasmas. But that's not all. That's all happening now. In the future, we're looking at using microwaves for actually constructing nanostructures, because microwaves can be targeted towards specific sites. This is called selective heating or selective application. So they're being used to actually build up artificial ceramopolymers as they're called. And what researchers are finding today is that using microwaves instead of conventional heating technologies actually gives them higher yields. And they are okay to get rid of the solvents, which obviously in a lot of industries is a major issue, because it lets you meet environmental regulations, takes away some toxic chemicals from the plant, and so on. At the minute, this technology exists in the laboratory. So there are a few companies around the world which are actually working on instruments for running these in the lab at the lab scale. But there have been some really encouraging signs which indicate that these can be scaled up to production plant levels. And we worked on a few projects on grafting of special nanoparticulate coatings on polymer substrates for various applications ranging from ballast water treatment to regular drinking water treatments and some electronic applications. But why are we talking about today? It's not new. Materials are being developed all the time. Materials have always existed. What's allowed us to revolutionize the industry today is the fact that we have understood how they can be used. So novel materials, or really old materials which we're rediscovering, are allowing us to make better designs. And that in turn is helping us create new applications. And it's a cyclical chain of innovation. For instance, there was a slide earlier showing a flexible circuit. There's one here that I was actually playing with yesterday on a sheep farm in Scotland. So they put these tags on sheep to identify them individually. Now they do that at the minute, but at the minute, they can only read the tag from about half a meter away. What they really want is to be able to let the sheep roam freely and read it from one central station. How do we do that? Right. New materials come in called artificial magnetic substrates. Now these are structural designs which mean that we can make better, smaller circuits, lower loss, longer range, all that. What does it mean? We can then put sensors under the skin because we can still get the same range without having to clip them to the ear. And that obviously leads to some other applications as well. So this chain of innovation is constant at the minute. It's not revolutionary, it's evolutionary, but it's happening. But 5 to 10 years from now, it's not just going to be these existing microwave infrastructures which will be in place. There'll be a new infrastructure in place. By new infrastructure, I mean new sources of energy, new sources of materials, which will allow us to harness the higher bands, like the terahertz frequencies. What would we use it for? We could use it for imaging. Now, this is an existing research prototype developed in the States. But the terahertz source used in here costs a lot of money. Once the costs come down, you'll start seeing them in medical applications or even in advanced processing techniques, because these frequencies will let you see your material or your structure at the nano level, which means that if you have structural flaws, especially in critical infrastructure, say oil pipelines or bridges or aircraft composite bodies, you'll be able to detect them during the manufacturing process, not as part of an inquiry after the failures happen. So I won't put any conclusions in here because we are just getting started, but the Internet of Things, which is all the components of any plant or a household communicating to each other, is estimated to be worth up to $14 trillion. It will take time to get there, but it's already started. There are already refrigerators which talk to all the food substance and the RFID tags on them to tell you if you're running out of milk. These exist. These are not mainstream, but they are already being sold in some parts of the world. There are environmental benefits to be had from using microwave energy. So as I said, we've shown examples. We've actually developed systems which save up to 50% of the energy for some of our partners. And communication systems will continue their upward march. So as in, we've gone from the days of the dial-up modems to having really, really fast streaming, high-definition video in our hands. But that's not all of it. It has implications which go beyond the obvious. If I have more information available in my hands, I'll try to get more information about products that I'm looking at. So it has knock-on effects for every manufacturer. So yesterday I was in Waterstones picking up a book for someone. Now, I didn't know what she would like. So I looked up, okay, what are the kind of books that a young girl would like? So I just searched online, went up to the teller, asked him, does he have any of these books? He led me to them, gave me the information on it. Now, this will actually become not a two-stage process, but it will almost become inevitable that Waterstones will, let's say, develop an application which will let you browse their books and give you and sell you the book straight away. And obviously it goes well beyond that. If I'm looking at a chemical product, I might use this material to look up if there's any carcinogens in there. That has implications because knowledge is now in the hands of the consumer. So all organizations will have to plan for this in some way or another. So just to conclude then, there's a massive impact being affected by the use of wireless technologies in various industries. There are lots of you in the audience here who are already using microwave technologies. For the rest, if you need to know how you can benefit from this, please feel free to come up to me and talk to me later on. Cheers. Thank you.